Hello everyone, so I'm going to go over 9.6 today, which is all about volume of prisms and cylinders. And so we've been talking about surface area for a couple lessons, and now we're going to talk about volume. These are both measurements that only apply to three-dimensional figures. Surface area would describe like the amount of space around an object or on the outside of an object. Volume would be the amount of space inside of an object. So if you want to fill up an object and know how much that is, then you would be calculating the volume of that figure. So there's some formulas that we're going to need to learn and apply. We can start with rectangular prisms. Just like with surface area, rectangular prisms are kind of special and, in my opinion, a little bit easier than all other forms of prisms. So if you have a rectangular prism, you'll be able to identify its length, width, and height. And the formula for its volume is just multiplying those three measurements together. So number one, it really doesn't matter the order that you put the numbers in, since multiplication, the order doesn't matter, but we can say 9 times 17 times 24, which would be our length, width, and height. And then you just multiply those across using your calculator. That would be 3,672. And one difference is that when we put our units, instead of labeling them as squared, we'll label them as cubed. That's to the third power, just because when you're dealing with volume, you're dealing with cubic units, like cubic centimeters or cubic feet. And we'll have to remember to put that little symbol after all of our units in this lesson and any lesson that has to do with volume. So looking at number 2, it's another rectangular prism. So all we have to do is multiply these three numbers together. So 10 times 14 times 4.5. If we type that in the calculator and get our answer, that would be 630 inches cubed. All right, and number 3, again, is one of those straightforward rectangular prisms where all we have to do is 8 times 12 times 39. And when you type that into your calculator, that'll give you your answer. It's going to be 3744 feet cubed. All right, so when you're dealing with another type of prism, such as a triangular prism, trapezoidal prism, or some other type of prism, the formula is a little bit different. It's going to be capital B, which stands for area of the base, times the height. So in this example, we have a triangular prism, and I just highlighted the bases. We need to find the area of that triangle, and then multiply that times the height of the prism. If you have a trapezoidal prism, you would highlight the two trapezoids and calculate the area of one of those trapezoids and plug that in for capital B. That would be the area of the base. So number 4 is a trapezoidal prism, and it seems like we have a triangle on the bottom down here and a triangle on the top. And so the first thing I want to do is calculate the area of the base. So I'm going to multiply this times this, and with 1/2, because the area of a triangle is 1/2 times base times height. This is 12. That 12 is our base of the triangle, and the height of the triangle is 7.3. That's different from the height of the prism. The height of the prism has to connect those two bases, so it would be this side, the 5. So when I do the volume, I need to find out what the area of the base is. So you can type all this into your calculator. That's 43.8. And then multiply that times the height of the prism, which is the 5. So 43.8 times 5 is equal to 219 feet cubed. So that's our volume. Number 5, we have another triangular prism. There's a triangle in the back and then one on the front. So I'm going to start by finding area of the base, which means 1/2 times base, which is the 11, times the height, which is the 5.4. And then find out what that area is. Comes out to 29.7. Now I can plug that in for capital B and then just multiply that times the height of the prism. In this case, it's this 16, whatever line connects your two bases. So this would be 475.2 millimeters cubed. Okay. Number 6 now is a trapezoidal prism. There's a trapezoid in the back and then another trapezoid here in the front. So let's start by finding the area of that trapezoid. The formula for that is 1/2 times height and then parentheses base 1 plus base 2. So let's do 1/2 times the height. Here we're talking about the height of the trapezoid instead of the prism. So that would be this line right here, the 17.9. The bases of the trapezoid would be this line and that line. So 36 and 14. 36 plus 14. Go ahead and calculate that area. It comes out to 447.5. Now to find the volume, multiply that number times the height of the prism, which would be this side, because that 25 connects the two bases. So this comes out to 11,187.5 meters cubed. All right, so then let's go ahead and flip to the next page and work with number 7. Something that we need to do on number 7 is realize that it's a triangular prism. So we're going to need to find the area of this triangle. But the problem is that we don't know the base of this triangle. We know the height of the triangle. And we know this side, which could be the hypotenuse of this right triangle. And so we could use that to find out what our base is by using Pythagorean theorem. So I could set up an equation that looks like this. X squared plus 28 squared equals 32.5 squared. And then go ahead and solve this. So we can solve by simplifying. 28 squared is 784. 32.5 squared is 1056.25. Then we have to subtract the 784 and bring it over to the other side. So once we do that subtraction, we're left with 272.25, and that's equal to x squared. Then we square root. So x is equal to whatever the square root of 272.25 is, which is 16.5. So that's our base of the triangle. So I'm going to use that now. 1/2 times 16.5 times the height of the triangle is 28. That gives me my area of the base, which is 231. So to find the volume, multiply that times the height of the prism, which is at 31. So 231 times 31 is 7,161 kilometers cubed. So this is our volume. Number 8, we have a trapezoidal prism. There's a trapezoid in the back and one here in the front. So what we need to do is find the area of that trapezoid. I have this side, and then this side down here is 39.4, which would also be this. The only thing I don't know is the height of the trapezoid, and I could kind of think of that by drawing in a line here, because I know that this is 30.6, and I could find out what this is by subtracting this and this, the 39.4 and the 25. So 39.4 minus 25 gives us 14.4. So that's what that little section is right there. So imagine that we have a right triangle. This is 14.4 and this is 30.6, and we want to know what this is. So we can just set up another Pythagorean theorem. X squared plus 14.4 squared equals 30.6 squared. And I'll show y'all a little shortcut. Since we square root at the end, we could just do that at the beginning. And instead of simplifying, we could just put this in our square root. And then we subtract this. So minus 14.4 squared. And then just type this whole thing into the calculator. And that gives you your x also. So it's just basically taking all the steps that we did above and merging it all into one step. And then it's faster, I think, because you can just type that in the calculator and you got it all in that one step. So the height ends up being 27. So I'm going to do 1/2 times 27. And then base 1 plus base 2, so 39.4 plus 25. That gives us the area of the base. It comes out to 869.4. So the volume is 869.4 times the height of the prism, which is 35. So that gives us 30,429 centimeters cubed. So remember that sometimes you might not have a measurement that you need in order to find the volume. And so you need to find that measurement using Pythagorean theorem if you can, or maybe just looking at some of your other sides and seeing if any of those are congruent to each other, and then you'll be able to find the volume. Let's talk about cylinders. Cylinders are pretty much prisms, except that their bases are always circles. And so we're still kind of doing area of the base times the height, except this is how you find the area of a circle, pi r squared. And so let's apply that formula to number 9. We're going to do pi times our radius, which is 18, and then square that, times the height, which is 15. The height here is still can be thought of as the line that connects to the two bases, which in this case are the two circles. So the volume for this comes out to 15,268.14 inches cubed. Okay, number 10. We have the diameter, that's 11. And I want to know the radius because that's what the formula is asking for. So to find the radius, I just need to take half of the diameter. So half of 11 would be 5.5, which means that's what I'm going to plug in for r. 5.5 squared times the height, which is 21. So that is equal to, 1,995.7 meters cubed, once you put that in the calculator. Number 11 is saying that a cylinder with a 2 centimeter diameter is drilled through the triangular prism shown on the left. Find the volume of the prism. So basically, we're drilling something inside of a prism and taking that out. And so our volume of the prism is whatever's left after you take out the volume of that little cylinder. So we can think of this as finding two different volumes and then subtracting it because we're taking that cylinder out of the prism. So we can start by finding the area or the volume for the prism. So that means I need to find the area of the base of the triangle. So there's a little tiny right angle there, which means this is our base and this is our height. So 1/2 times 5 times 5 comes out to 12.5. And then the volume would be that 12.5 times the height, which is 14, which is 175. Next, I can find the volume of the cylinder. So the volume of the cylinder is going to be pi times r squared. Well, if we have a 2 centimeter diameter, the radius would be half of that, which would just be 1. So pi 1 squared times the height of the cylinder. The height of the cylinder is the same thing as the height of the prism. So it's also going to be 14. So pi 1 squared 14 comes out to 43.98. And so the volume of the prism of whatever's left is whatever we get when we subtract these numbers. So 175 minus 43.98 is equal to 131.02 centimeters cubed. Okay, and then number 12, a diagram of Eric's pool is shown on the left. He plans to fill his pool to a depth of 4 feet with a garden hose that has an 80-foot cube per hour flow rate. How many hours will it take to fill the pool? So if we're filling this cylindrical object, we essentially want to know the volume of this pool. So let's think of trying to find the volume of this cylinder. It's going to be pi r squared at first. So pi, I don't know the radius, but I can find it because they tell me that the diameter is 27. So half of 27 is just 13.5. So that's going to be the radius squared. And then times the height is 4, because we're only filling it to a depth of 4 feet. We don't want to use the 4.5 in this case. We just want 4 because we're not filling it all the way to the top. So when you find that volume, that gives you 2290.22 feet cubed. And we're filling up this pool to this volume 80 cubic feet per hour, and we want to know how many hours. So we're just going to divide that number by 80 to figure out how many hours it's going to take to fill up. This comes out to 28.63, and then let's label that as hours since we're talking about hours. All right, so that's it for 9.6. Make sure that you complete the homework and the exit ticket, and I'll see y'all in the next lesson.